Hello class. In this video I work example 2 from section 6.6, the area between two curves, on page 94 of your note packet. So here we're given the graph, okay, of two functions. All right, we're given the graph of 2x squared minus 6 and 2x minus 2, and we want to find the area sandwiched between those two functions. And so we're looking at this area right here, okay, between shaded in black here, between the two functions. And so to calculate that area, right, we got to know the two values of x where the functions intersect, where they cross each other. Well, by visual inspection, you can see that they cross here at x equals minus 1, and you can see that they cross over here at x equals 2. So A is equal to minus 1 in this case, and B is equal to 2. Now you can also verify that algebraically, okay, because where they cross, the two functions are equal. And so we have 2x squared minus 6 is equal to 2x minus 2, where the two functions cross. And then when I subtract the right-hand side, move it over to the left-hand side, I have 2x squared minus 2x minus 4 is equal to 0. And when I can factor out a 2, right, divide both sides by 2, and I'm left with, well, I'll factor out the 2. Right, I have 2 times x squared minus x minus 2 is equal to 0. And then when I factor the quadratic, I have 2 times x minus 2 times x plus 1 is equal to 0. And then when I set these two factors equal to 0 using the zero product property and solve for x, I get x is equal to 2 and x is equal to minus 1, right? Which I pointed out, which we already knew by visual inspection, okay? That those were the two values of x where the two functions cross each other. So this straight line in blue is the top function. So if you want, you can call that f of x. And this curve, the parabola in red, right, that's the bottom function. You can call that g of x if you want to, all right? And so to find the area sandwiched between the two functions, right, we take the definite integral from x equals minus 1 to x equals 2, the top function minus the bottom function. So the area, shaded in black, is the definite integral from a to b of the top function minus the bottom function, right? Or you can say upper minus lower, doesn't matter. And the top function, in this case, is, well, before we do that, okay, let's do the algebra first, so we don't have to do it inside the integral, right? Top function is 2x minus 2, bottom function is 2x squared minus 6. So let's do top minus bottom first, so we don't have to do it inside the integral. The top is 2x minus 2, and the bottom is 2x squared minus 6. And now we got to simplify that algebra, okay? So when you distribute the minus sign inside the parentheses, right, we have minus 2x squared plus 6. And now we got to simplify. 6 minus 2 is 4. And we have the plus 2x. And then we have the minus 2x squared. Now you might write it as minus 2x squared plus 2x plus 4. That's just fine. Okay. Now we can replace top minus bottom inside the integral up here. Right. Now that we've done that algebra outside the integral. A is equal to minus 1. B is equal to 2. And top minus bottom is 4 plus 2x minus 2x squared. And now all we have to do is evaluate that definite integral, and that'll give us the area shaded in black here, sandwiched between those two functions, okay? So the antiderivative of 4 plus 2x minus 2x squared, antiderivative of 4 is 4x, antiderivative of 2x is x squared, and antiderivative of minus 2x squared is minus 2/3 x cubed. And the limits of integration are from -1 to 2. And now, to find the area shaded in black, we got to put in the upper limit of integration, 2, and we have 4 times 2 plus 2 squared minus 2/3 times 2 cubed. The picture's almost too big, right, for this board. And now I got to subtract and put in the lower limit of integration. And always, right, when you have multiple terms in your antiderivative, right, put everything inside parentheses when you substitute the lower limit of integration, or you'll just change the sign of the first term and not the second, third term. So then we have 4 times -1 plus -1 squared minus 2/3 times -1 cubed. Right? That's a lot going on right there. Okay? So we put in the upper limit of integration, and we have 4 times 2 plus 2 squared minus 2/3 times 2 cubed. Then we subtract, put inside the parentheses the lower limit of integration, 4 times -1 plus -1 squared minus 2/3 times -1 cubed. And now you got to do all that arithmetic and hope that you don't make a mistake. Okay? So, when you do all that arithmetic and don't make a mistake, somewhere along the line you end up with 15 minus 6, which is equal to 9. I'll leave it up to you to verify the arithmetic, okay? That once you simplify what's inside the parentheses and you distribute the minus sign and you do all that arithmetic, okay, you end up with 9 square units as the size of that area sandwiched between the two curves, okay?